Hello students, we are going to study the topic magnetic effect of electric current. Okay, so I am saying magnetic effect of electric current. First, you all know what is electric current. We have studied in the last video, isn't it? But yes, what do we mean by magnetic effect? Do you know first of all what is a magnet? You all play with it at home, I think so, isn't it? I have also got a small piece of magnet in my hand. Okay, its property is what happens when I keep a safety pin near it. You can see what happens. It has got magnetic properties. As the result, what happens, it attracts this iron pin towards itself. Okay, so this phenomenon we will be studying here also by applying what electric current, even though it is not a permanent magnet. Actually the magnets which you all have, with which you all play, okay, it is a permanent magnet. It has the property of attracting the iron substances towards, or iron materials towards itself. Okay, but by electricity also we can see magnetic effect. How? See what happens. Take a wire, okay, simple wire which can conduct electricity. Okay, it has got a battery, positive and negative terminal. Okay, it has got what? A switch. This is just a circuit diagram, isn't it? What happens when this is an open switch, so this is what? This is not a closed circuit, this is an open circuit. As soon as we switch on, what happened? The circuit becomes closed. Okay, keep a compass over here. Okay, now here what will happen? As soon as we are closing it, it becomes a closed circuit. Electricity is flowing through it. We will be seeing that when we are closing the circuit and the electricity is flowing inside it, or the current is flowing inside it, what happens? This compass will show deflection. Okay, this is a magnetic compass and it is showing what? Deflection. It means when current passes through the wire, it has got magnetic properties also, and due to that magnetic properties, this magnetic compass showed the what? Deflection. Okay, now next step, just what I have done here now. This is not a closed circuit now. Okay, then you see that compass remains in its original position. So this experiment proves that when electricity flows through a conductor, it produces what? Magnetic effect. And this is what the magnetic effect of electric current. When electric current passes through the conductor, what happens? It produces magnetic effects. Okay, now coming to solenoid. What is a solenoid? Actually solenoid is the turns of the conductor or the wire which is coiled up to form number of turns. Okay, this is known as, this coiling of wire is known as solenoid, which is joined to the battery. Okay, as the turns are more, as if the number of turns are more, what will happen? It will produce more magnetic effect. So more the turns, more the magnetic effect. Lesser the turns, less the magnetic effect. Okay, so this turning of this wire is known as what? The solenoid. Okay, now electromagnet. When we are talking about the electromagnet, you can see this is a solenoid only. Okay, the turning of coils are there. Here what is there? A material has been inserted. Okay, that is the soft iron and it is known as core. So here when we talk about solenoid and electromagnet, the difference is that of addition of this soft iron core over here inside it. Okay, and nothing else. Actually what happens when this is inserted inside it, its efficiency becomes more. It becomes more efficient and to produce the magnetic effects, and as the result it acts like now what? A electromagnet. till the electricity is passed, it will behave like a magnet, and when the electricity is switched off, it will not behave like a magnet. Okay, electromagnet only behaves when electricity is passed through this solenoid. After that, it will not behave like a electromagnet. Switch off, magnetic properties also goes off. Actually, what happens, this electromagnet, when we talk about this electromagnet, from the usual magnets which we have, the permanent magnet, these are more efficient. They can pick up big things. Okay, in the industries it is used. The cranes and all use this to take out or to clear off the scraps of the metal. Okay, because it has got tremendous amount of magnetic effect that it can even lift up heavy things. Okay, which can't be done by a permanent magnet. In case of electromagnet, when we are seeing, we can manage its magnetic property by switching on and switching off. You know that when it is switched on, okay, it behaves like an electromagnet. When it is switched off, its magnetic properties goes off, isn't it? So here we can say this electromagnet is very, very useful in removing the scraps, the metal scraps and all, okay, efficiently. If it is present, it is used in industries mainly to do all the work. Okay. Now let us see one of the application of magnetic effect of electric current. Okay, you all have electric bells at home, isn't it? Now how it works, just understand that. I made the figure that the electric bell consists from inside. Okay, above it is covered with the box, but inside what structure is there in the electric bell? Okay, actually you can see number of bells, some are connected to the switch, but most of them has got what? Battery. Okay, so battery is placed over here. Here switch on and off. Okay, open or close circuit, for that switch must be there. Okay, there is what? A screw, there is what? A hammer, there is an iron bar, and here you can see this is also iron only, but just it is wounded with what? The conductor or the wire, and this is the gong. Okay, so here what happened when the switch is disconnected, or it is when the switch is open, or when the circuit is open, okay, we can't see anything. But what happens as soon as we switch on, or okay, as soon as the circuit is closed, what happens? Current passes. Okay, and as the result, when the current is passing through this iron, it produces magnetic effect, isn't it? And as it produces magnetic effect, when the current is passing, it is behaving like a electromagnet. Okay, and when it behaves like an electromagnet, what happens? It attracts this iron bar towards itself. As the result, what happened? Here you can see a disconnection. Okay, and what happened? It strikes the gong, and as soon as it strikes the gong, you can hear the bell ringing. Okay, but when it strikes its gong, what happened? The circuit becomes disconnected over here, you can see, because here a space is created, isn't it? So what happened when it becomes disconnected? This electromagnetic property of this iron gets lost, and as a result, attractive property is also lost. Okay, and this iron bar now moves up and again gets connected to this screw. Okay, and when it gets connected to the screw, naturally then again electricity starts passing and you can hear the bell. Okay, this is how an electric bulb operates. Okay, electric bell operates. Okay, so this is all of the electric current and its effect. Okay, beta, the chapter is not so big. Hope you might have understood it. Good day, take care.